guess I'll do, Ben pretty much did my intro for me, but this is about me. The one thing he didn't add that he probably didn't know is I'm a self-taught developer, so a little bit of a non-traditional background, like a lot of you guys here. I studied mechanical engineering and business in school, and so getting into programming was kind of like a hobby, and then it turned into web development, and we can talk about all that later. And right now, I am the CTO at the Graide network. I put air quotes around that because we're a tiny startup, so CTO means it's basically me and occasionally a contractor. But before that, I worked at Packback where I managed a team, and it was a little more of a management role. So very much hands-on in the dev these days. Okay, so 4 sort of parts to this whole story and what we're going to talk about today. The first is we're going to go over what it means when I say the term incremental development. We're then going to talk about what microservices are. And then we're sort of going to drive the point home with a couple of stories, like real world. These are applications that I've gotten to work on in the last few years. And so hopefully the illustrations will be the most enlightening, but it's sort of necessary to get a little bit of a baseline so that we're on the same page as far as terminology goes. So where are you guys at currently in the like learning process, learning how to develop? Somebody want to give me a summary?
I'll give you a summary.
Excellent.
So you've got 2 groups of people. You've got one group who's about 4 weeks into the curriculum and done back end, front end. Then you've got another group who's about 10 weeks into the curriculum who went through all the core curriculum, is now in the project phase, like putting all the pieces together.
Okay, awesome. So for those of you a little further on, you have seen a real project, or you're seeing a real project come together, which is great. In the real world, this happens all the time. That's pretty much all we do is put together real projects or update existing projects. And the term that I like to use to describe that is incremental development. And when I say that term, it's not something like special and fancy that I made up. Basically, all it does is describe how all software is built these days. And so let's start with an analogy from the physical world, just to bring this into something very concrete. Hopefully, we'll all be on the same page after this. When I come up with an idea for a business or something that I want to create, I'll typically think about that for a while. And my idea in this case is people may want to sit down. So let's take ourselves back to before the advent of chairs. People want to sit down. They've been sitting in the dirt for a long time. I want to try selling them something that they can sit on. So what I'll do is I'll put together an MVP, or a minimum viable product. How many of y'all have heard that word before? Oh, awesome. You guys, anybody read The Lean Startup? Is that? Okay, cool. So that's another, if you get into product development, you should look into that. But basically, my MVP is going to be something super simple that I can prove that people will pay for so that I know it's worth developing this further. So in the case of the chair, it's going to be just a wooden block. It's better than sitting on the ground, but it's definitely not a real chair. Over time, what we're going to do with that minimum viable product is refine it and figure out maybe by the time we get to this stage, this is what we're going to call a version 1 of a chair. It's like a real, actual chair with a back. And then by the time we get to this pretty one, this is kind of our version 2. The point, though, is that this does not happen overnight, and we also didn't go straight from idea all the way to finished version 2, right? There were a lot of steps in between. And when we build software, this is done basically the same way. So typically in software, what we do is we start out with an idea. We build our first version of the product, maybe an MVP or a version 1, whatever you want to call it. The designation isn't that important. And then over time, what we'll do is we'll take components of that version 1 and replace them. We'll take other components and we'll carry them forward. And by the time like 6 months or a year or 2 years has passed, we've got a whole new version of the product. But the important thing here is that it's built along a continuum. It's not like we stop supporting an old version one day and flip a switch to a new version, at least not very often. That does occasionally happen. Typically what happens is we're slowly improving the software over time. Y'all with me on that? Everybody make sense? Cool. Okay, so let's kind of jump back to that last slide because I want to point out one thing here. When we build software, we're building components. How many of you guys are familiar with the idea of a class, like a class in software? Good, I hope almost everybody, that's awesome. So very good, because that's often a like really commonly used component. Another thing that might be considered a component is like a third-party library. So how many of you have imported a package using NPM, probably? Awesome. So you've got the idea about what that's like. When we talk about microservices, what we're really talking about is making each little application one component in our system. So think about that for a second. Let the words sit in. And this is what it looks like. So you all are, maybe, how many of you have heard of an MVC architecture? So it's Model View Controllers, what that stands for. Some of you are maybe further along, have probably seen that or heard of that. The idea in a Model View Controller is that we have a model, which is a class that interacts with the database. We have a controller. Typically, that's going to take requests in and sort of route them to the correct models, pull data, and then shoot out a view of some kind. And then we have a view class, which is the presentation layer in our application. But all of this in a traditional application is one big repository, one big GitHub repository that we serve on one server typically. And it's what we might call a monolith, which just means it's sort of one big thing. When we build microservices, what we do is we get a lot of little services together. So instead of this one application, we actually have like 3 different applications, each with their own database connection, and maybe a front-end single-page application, something like Angular or React, to link all the data together, pull the data, create a view, and render it. The advantages that we as developers see for microservices, the reason that it's sort of gotten more popular is that they're really highly encapsulated. So if we go back to this last diagram, if you were going to, in a traditional MVC, let's say that we wanted to query all the users and their posts together. So those are both in 2 separate models. There's a user model and a post model. But in order to query both of them at the same time, we can do a MySQL or a SQL join operation, and it's going to pull both the data at once, right? So what's really cool about that is it's really fast to get both of those objects together. The challenging part about microservices is that you can't necessarily do that because they're living in separate databases. So we have to come up with some unique solutions to deal with that problem. But the plus side is, the advantage is that they're really highly encapsulated. So new developers can't come in and start putting logic that should live in the post microservice into the user's microservice. It's just really hard to mix those things up because they don't work together. They can be faster. We can scale them independently, which is really helpful. And it can help a lot once we get to larger teams where multiple teams, each one might actually maintain its own microservice. And like Amazon is sort of notorious, and I think Netflix as well does that. Yeah?
When you say they're faster, do you mean that they are more performant or that they are faster to develop?
Well, it depends on who you ask. It's sort of like all these advantages are, it depends. But yeah, they can be really fast to develop each individual piece. Composing them as a whole, though, that's still like any large application is going to take time. The sort of faster that I meant for this is really just that they can be more performant because you're not letting them worry about the parts of the application that don't matter to them. So in a traditional MVC app, something like Rails, which maybe y'all aren't familiar with Rails, but Rails sort of bundles in a ton of packages together for you and then gives you access to all of them at once. That's inherently a little bit slower than just taking the packages you need and using only them. So with microservices, we're typically building things smaller, not with as many packages. With a traditional MVC framework, we're probably going to pull in as many packages as we can because we just want to have everything available. So there's some performance benefits there. The disadvantages is that one of the biggest ones is that testing across the boundaries of these microservices can be tricky, and you have to come up with some new strategies. Writing complex queries, like when I want to get users and posts together, can be more complicated. Dealing with multiple servers is more complicated. How many of y'all have gotten to deploy something to a real server yet? Some of the people further along, I'm assuming. Awesome. So how easy or hard was it to get something deployed, and how'd you do it? Somebody tell me. Use Heroku, good. And so deploying to Heroku is actually pretty easy, which is great. So anything you can do to make your deployments easier is excellent for microservices because we're going to be deploying a lot of things a lot of the time. All right, so let's talk some true stories. I guess I'll stop for a second here. I meant to put a questions slide in. Does anybody have any questions so far? Anything that I can answer? Maybe we'll get more questions with the stories. Okay. Yes?
I don't know, maybe this goes off topic, but
Oh, that's fine.
if this is a microservice, what is it? You define service.
Yeah, that's a good, I should have done that. That's an oversight. So let's define service and microservice both. How many of y'all have worked with an API like a Facebook API or Twitter API or something like that? People further along, probably a couple of other people. Awesome. So the idea here is that other companies will expose what they call an API that will allow us as developers to grab data or add data to their system without actually like writing code in Facebook, right? When we write microservices, we're essentially building little versions of that for our own internal use. So typically microservices talk to each other via HTTP, which is the same method that a REST API will use. And a lot of times they are RESTful APIs, but that's kind of beyond the scope of this. Basically what we're doing though is we're setting up microservices on separate servers and then having them talk to each other and talk to a front end through API requests. And so that's what I mean when I say service, is kind of like each of these little things, instead of calling them an application, because they're not really a full-on application yet, they are a service, so a little piece of an application. All right, so some true stories. So I worked at PackBack up until about 1.5 years ago. Was their head of engineering or director of engineering. You can call it whatever, I guess. But basically, what we did at PackBack initially, when I joined the company, we were on Shark Tank. We got about $500,000 from Mark Cuban, a couple other big people in the Chicago area. And our premise was we want to be able to rent digital textbooks to college students for $5 a day instead of buying the whole textbook for $200 or whatever it cost. So awesome idea. I still love that idea. If somebody goes and runs with it, that's awesome. PackBack has since pivoted, and they now make software for professors, and we'll get into why that happened, how that happened. But basically, the trouble we had with the whole mission of like getting textbooks out there is we have a two-sided marketplace. We had to get publishers to allow us to distribute their books, and we had to get college students to know about our service versus the millions of others that sell textbooks like Amazon, Chegg, Book Renter, et cetera. And we had to market to them. So it's really expensive and time-consuming and complicated problem to solve. But from an architectural standpoint, to kind of back out of the business side for a second, this is what we initially set up at PackBack. So we built a whole textbook rental platform on microservices. We had a users API, a search API, and a books API, each connected to their own database and a front-end Angular application. And it all worked really well. It's really scalable, good stuff. The problem we had was that publishers weren't giving us access to their textbooks. Because publishers didn't give us access to distribute their textbooks, we couldn't convince students to come use PackBack because they couldn't get all their textbooks here. Publishers want us to have students in order to distribute textbooks through PackBack. So this sort of like cycle of we need one to get the other. That's what they call the chicken and egg problem. So one of our solutions, or our proposed solutions for solving this problem was, let's build another product that professors use in their classroom that we can use then to sort of springboard into marketing textbooks, which makes sense. A lot of companies build side projects to sort of promote their main project or product or whatever. And so that's how PackBack Questions started, which now PackBack Questions is what PackBack does. So it's kind of cool that this became the dominant thing. But we didn't know on day one of trying out PackBack Questions that it was going to be like a major focus of the business. So PackBack Questions is a question and answer community. So college students sign up, their professor is sort of the leader of their community, and then the students ask and answer questions to each other. It's kind of a way to gauge participation in the class, especially in those big lecture halls where there's like 200 students and they don't get to actually have conversations with each other. So professors will look at how many questions have been asked and answered and kind of use that to give extra credit or points to their students. So it started off in a very humble way. And I know we're talking about programming and microservices, but this is not programming. None of this was programming, and that's what's kind of cool about the whole story. We started off, we just wanted to test this out with 5 professors, got about 100 students at a really friendly school where we knew all these people. We manually created reports for the professors, and all we did was students would sign up on this thing called answerbase.com, which is a white label Q&A, like Quora kind of platform. And white label just means that we could put our own styling and logo on it, and they were cool with that. So they'd sign up on AnswerBase. We would store their information in Google Drive just to keep it coordinated between people and the professors, and then we would send out emails to remind them to post questions every week via MailChimp. So completely no programming technical solution to this problem. The challenge was, as we got into using this for a while, we didn't know, one, would it scale? We didn't know, two, could we make this its own product? So we tried marketing textbooks through it, didn't do super, super well. So what we said was, well, what if this is what Packback becomes? And this is where the sort of like pivot started happening. It almost happens like without us realizing that it's happening. But we decided, let's test, will students, could they pay for this as a part of their course fees? So we put a simple payment form through a company called Wufoo. And then we hooked that up through Zapier to send people who paid to MailChimp and Google Drive. How many of y'all have heard of Zapier before? I'm like a big advocate for Zapier, so go check it out after this. What Zapier does is it does a lot of the work that we as developers do, which is awesome. We should know about tools that compete for our jobs. So Zapier allows you to, like, I guess, like, back up a bit. The trend these days has been more and more companies are putting out APIs, right? So Facebook's got an API, Google's got hundreds of APIs, and all that data is already out there for a lot of our users. So we as developers are more and more just pulling together like data and information from APIs or functionality from other APIs rather than building everything ourselves from scratch, which is great. Zapier's kind of seen this trend, and they've said, well, we're going to make a way for non-technical people to pull together these APIs. So kind of a nice graphical user interface that allows you to say, when a user fills out this form, send their information to MailChimp and to Stripe or something like that, right? So it allows people who are non-technical to kind of set up semi-automated or fully automated scripts that do things that we as developers would have had to do a few years ago. So our business team kind of set this whole little stack up, and they realized, well, we've got the students in Google Drive at some point, but we need to import them into AnswerBase automatically. And so we had one little script that would do that every week or every day or something like that. And that was kind of the only development work that went into this. And we were able to scale this up to a few hundred students and prove that people would pay for it, which was exciting. And so now Packback's really starting to make more and more of a pivot. We're deciding, okay, people are paying for it. It's maybe worth investing more engineering resources in. The biggest challenge we had was we had one intern whose job every Friday was to go through all of the questions and answers posted on AnswerBase and count up how many had been asked by which students. If that sounds awful, I'll put you in touch with the intern who did that. She can tell you how awful it was. No, it was just like, you know, we only had a few hundred students, so it was possible, but it was a huge time-consuming task, and it was not fun to do. But once again, we're testing things out. So the next sort of step in automating stuff was to start to write what I'm calling disposable architecture. And these are small services that we knew were not going to last forever because we had already realized this is going to become a bigger part of what we do. We need to rebuild the whole thing in-house slowly. But instead, what we did was start off just by building some disposable apps that kind of would munge this data together in a way that we want it to. So we basically replaced Zapier with our own custom code. And at some point, everybody outgrows Zapier. Zapier is awesome, but it doesn't answer all the problems. It doesn't do everything that we might want it to do. So we ran into some times where it didn't work. We also wrote a report generator, which took that intern's Friday job away. She had plenty of other things to work on, though. And then we were able to scale this up to 5,000 students, so pretty good scale for an early stage project. And throughout the process, we kind of learned what it was our question and answer platform needed to do really well. The challenge we had there was that we knew this was not going to scale. Our disposable applications that we built for this disposable services we wrote, microservices, whatever you want to call them, they were pretty buggy. We didn't write a lot of tests for them. We knew they were only going to be around for a few months, so we sort of like cut corners on them. And you know, that's a trade-off we were sort of willing to make. So we did eventually decide it was time to do a complete rebuild. As we realized this is more and more what we're going to become, we need to own the platform. We didn't want to be, you know, for business reasons, we didn't want to be completely reliant on a third-party white-labeled service, which gets messy once you have investors and all that. And so we started work a couple months before that last slide on a complete rebuild. The nice thing was, because we had already built this books world, so we had this textbook rental platform with books and search and users, we were able to kind of like reuse some of that work. So we reused the users API, which handled user logins and checkouts, for our questions application that we eventually built. So we created a new microservice for the questions and answers and comments, and then a new front end for it, a new database, but we were able to hook into our existing users API. So it was a lot less work. I'm just going to add a couple takeaways you probably picked up on. But one, I love building stuff in third-party applications because it means I do a lot less work. And I think more and more development jobs are becoming merging third-party applications, open source software, et cetera, together rather than writing everything from scratch. And I think that's really smart. It's really exciting. It's really fun because it frees us up to like solve real business challenging problems rather than just like, I don't know, I need to make an email client again. It's been done so many times, there's a way to do it. So no shame in that. Don't think you've got to rebuild everything from scratch. And then the second thing is that doing a complete rebuild of a system, even when you've got this sort of like hacked together thing to work off of, is much harder than it looks like up front. When the last, I guess, 2 companies that I've come into, Packback and the Graide network, both had an existing legacy platform, which just means it had been around before any of the developers that were there working now had been hired. So these old platforms that no one really fully knew how they worked, and we talked at length about rebuilding them or refactoring. And refactoring is just taking little pieces and improving them slowly. And there was always this desire from developers to rebuild because nobody understood how it worked. There's no tests. It's scary. Let's not touch it. Let's just rebuild it. But the challenge is without knowing every single specification that exists in the application, which we didn't have recorded, you can't do a complete rebuild. It's impossible. So you almost always lose some functionality, and it almost always takes longer than you think it will. So be wary of that. I'll stop here for questions. We can look at any of those diagrams. Anybody have anything they want to like dive into? Yes?
So for your backend microservices, you mentioned you were using Laravel. I'm wondering if you were running those on separate servers or if those were just kind of separate portions of a single Laravel application, and why?
Good question. Yeah, you can do it either way, and there's no right and wrong answers. The way we did it at Packback was to run each microservice was one Laravel application, and it was on its own server. And the reason for that was that, well, a couple things. One, servers are cheap these days, so there's no reason not to spin up servers if it's automatic anyway. And it allows each server to scale independently, which so sometimes when we got to this point where we had realized that the questions and answers thing was going to be more of what we did, we could scale these servers up and we could sort of like scale these down to save us money. So that's the advantage to that setup. But at smaller companies, like what I do at the Graide network now, we actually run all our microservices on like 2 servers and just run a redundant copy just to like make it really simple. So I don't have to manage like 10 different servers. Yeah. Yeah.
How big was your development team? Like, how did you break up?
Good question. We were between 3 and 6 people, depending on when you ask that. And we basically had 2 people working, or roughly half the team on front end, roughly half the team on back end, and then we had probably 2 on front end, 2 on back end, and a couple floaters, like 1 design and front end person. Yeah. Yes.
Is there any kind of setup you needed to do or decisions that needed to be made in terms of handling like session information or remembering users' logins and so on in terms of like the actual HTTP request coming into one of these? Is there like a server in front of all these servers that will like route someone like, oh,
good question.
log in or not, send them to the user's database first, or
Good question. So you can certainly do that. And actually we are we're going more in that direction at the Graide network. Architecture evolves over time. You don't necessarily, you make this grand plan and then things do or don't happen the way you want it to. And actually we want it to be this way. So we had a really good senior front end person at Packback and a really good senior back end person at Packback. And they were pretty confident they could do an OAuth setup where you could go to any one of the microservices and they would check that the token is still valid. So we kind of had basically, at least when I was there, and they may have switched this up because they may have switched it up. But basically the way we did it was when someone from the questions front end would make a call to the questions API, it would check with the user's API to see if this user's token that they passed in is still valid. And if not, it would send a bad response. If they were still valid, we would give them whatever data they were allowed to get. And so that's one way to do it. We'll look at the other way to do it at the Graide network, and I'll make sure and point that out because I kind of like that, the second way, a little better now. Yeah?
From an architecture decision, there's obviously something abstracted there in this diagram of the connections that the APIs make to each other.
Yep.
What's the point when you're like, oh, these 2 things, this API needs to be split into 2 things? Or what's the point when like, oh, these 2 APIs are basically passing every piece of information back and forth and you need to
Yeah.
put in the same service?
That's a really good question, and I wish I had one answer, like, or the answer, you know? I don't think, yeah, I think boundaries, so defining boundaries in software is probably one of the harder things to do, and I still struggle with it often, whether it's the boundaries between two microservices or the boundaries between two classes. I mean, that happens all the time where I'm building like a transporter class, and I'm like, oh, should it do validation at all? Should it do any conversion of data, or should that be another class entirely, or should that be a trait or an attribute or something weird that I throw on there? So I don't know exactly what the answer is. We were always balancing the sort of simplicity of each service. So like I want a new developer to come in and learn one service within like a reasonable amount of time, usually a day or two if they're at least more seasoned. So they could come in, learn the questions API, all 10 or 20 endpoints that it had, pretty quickly. But they didn't have to know a ton about the other APIs that existed, how they worked, but they could at least get the idea of how one works. And once you have the idea of how one works, you kind of have the idea of how they all work, which is what's nice about this sort of setup. It's repeatable. But we often had discussions where it's like, well, is it time to break what I think one of the big ones was like transactions. So users were paying and logging in through the user's API. Those are probably not that related, and they probably could have been a separate service. But then we're like, well, we got to maintain one more server. We've got to rewire all the existing stuff. So once you get a certain amount of like architecture out there in the world, it gets harder and harder to pull back and say, oh, we should have broken that up. So I don't know that there's. I know that that's not a satisfactory answer, but there is no satisfactory answer. It just depends on your team, your desire. Like companies like Amazon will try to make each of these services as small as possible when they first start because they know they're going to grow to be huge and there's going to be 20 engineers on it in a few months or whatever it is. So their priorities are a bit different. Yeah. So I have a whole presentation on that, and that's the other one that I'm pitching at conferences. So Ben mentioned I've been like, I'm pitching two talks at conferences for the last few months, and that one has actually gotten way more acceptances than this one, even though I think this one is more interesting, but whatever. So the testing distributed architecture, so this is distributed architecture, and when I say distributed, what I mean is there are multiple servers, and each one of these servers are completely separate entities. I saw a really good definition for distributed software that said, distributed software means that when a server or a computer you didn't know exists turns off, the whole thing dies. And so that's really good. I think that's pretty accurate. So hopefully it's not the whole thing, but part of it dies, and that does happen. So we would have a server for the front end, a server for the books front end, a server for the questions, server for the books front end, server for each of these APIs, and then the databases could even be on their own servers, depending on how we had it configured. And so that means like for one web request to come through, 10 servers might have touched that request at some point. That's a lot. I mean, that sounds crazy, but it's not actually that unusual in any kind of larger system as it grows. So the way we write tests around that, to get back and answer your question, is a whole presentation. And the way that I like to think about it is we want to test each of these services individually in their own layers, like unit test each piece. We want to integration test multiple pieces together. We want acceptance test a lot of it together. We want to also really test these boundaries between services, so the boundary between the API and the front end, or the boundary between the API and the database, just to make sure that they are working as expected. And then we want to do some end-to-end tests around the whole thing to make sure the whole thing actually stands up in a test environment and works. So there's no strategy that like eliminates the problems completely. There's some really cool things done at bigger companies that deal with this problem on a massive scale. You know, these startups I'm talking about were, hundreds of thousands of users. That's not the scale that Netflix operates at. They're operating at millions and millions of requests all the time, lots of data. And the way they deal with it is they've got stuff that like randomly goes through and shuts down services to make sure that there's no, they call it Chaos Monkey, they've got a library for. It shuts down a random microservice and says, all right, does the whole thing still work, or did it just all die? And they just don't want the whole thing to die, so they'll sort of accept some degraded performance depending on what it is, the function they're shutting down. But kind of interesting how they do that. So there's stuff you can do. Any other questions on Packback and this microservice approach? Yes?
Kind of off that note of like handling like failures of servers, like how is like that sort of like dependency and like DevOps kind of work managing a system like this over managing a monolith? Like what's the like differential there?
So a lot of this, the choice to do it this way versus to do a monolith all on one server, and when I say monolith, I'll mean one server architecture. It depends how comfortable you and the rest of the development team are with working across multiple servers and deploying stuff. So I've felt for the last few years pretty comfortable with that setup, and setting up servers, once we write the automation scripts, should be what I'll say is trivial, which just means easy. It's like I don't know, people use that word too much, but it should be easy to set up a new server. I should be able to do it in a couple minutes, not hours or days or whatever. So if that's the case, you have someone on your team who you know is going to be there, who can set up a server in a couple minutes, then, and because they have the right automation scripts or tools, then you're safe for going with this approach versus no one on your team knows how to set up a server. In that case, definitely want to write something very monolithic on one server because that's not your strength. So with a small team, you're just kind of like, where do our strengths lie? With a larger team, if it's enterprise stuff, it just becomes a problem of scaling, and like we need to be able to access certain resources with a certain reliability and stuff like that. And so multiple servers becomes pretty necessary. Yeah.
So another aspect of this whole thing is scaling on Z-axis and like CDNs and just like pushing out the information closer to. Does this have any impact on how easy or difficult that is to do?
So with we only at Packback dealt with a CDN in terms of serving up the front end, and we would, I guess, like as far as I didn't cover redundancy in these diagrams because it's just a little bit it goes probably too far for this talk, but I'm happy to answer the question. So both of our front ends were served via CDN that was highly available and distributed across at least the country, probably the world. It was Azure, so their stuff's pretty much worldwide. And a CDN is a content delivery network. And all that means is a CDN will have it will take your code and put it on lots of different servers around the world. And whenever someone asks for your code by going to your website, it serves it from the closest one possible so that there's even less latency or whatever. And also it can serve as kind of like, oh, one of our locations went down, let's just have another one up immediately and it's already there. So for larger applications that need to be up all the time, you typically want your front-end assets or all your assets served via CDN. Our backends, though, we would just have like 2 copies of them in 2 different regions in Azure, and or 1 copy in each region, so that if one region went down, the other region was there, and we'd just be ready to switch the DNS records over if that ever happened. But to be honest, like when you're a small startup, your uptime promise is much lower than Azure's, so I don't know that it's a problem we had to solve that much. They're probably dealing with it more now that they've grown a little bit larger than when I was there. Yeah?
What do you use for server provisioning?
So with PHP, there's a really cool tool called Forge, and it's written by the guy who created Laravel, which is the framework we use. And so it does most of the work, about 90% of the work for server provisioning for us at both Packback and the Graide network. I really like Heroku for side projects, stuff that I've worked on in Node and PHP as well. Like it just is like there, and you can scale up those dynos whenever you want, which is nice. The other strategy that I've been using lately is more container-based, and I didn't really get into that for this presentation because that's a whole bag of worms, but we can talk about it later. Yeah. Okay, I'll keep going because the next story is, it just goes deeper into a different example. So at the Graide network, when I joined, the challenge that we were facing was one of, we had a lot of existing code, and I was the first full-time developer to be hired, and so the team that had built it was overseas and just there temporarily. So they sort of threw something together, put it up, and then it worked sometimes. What we do at the Graide network, just to back up a second further, we allow K through 12 teachers to upload assignments to our platform, and then we find college students who grade their papers for them. So for high school English teachers, for example, one of the biggest challenges in assigning more written work, like more essays, is that they have to spend all weekend grading it. Were any of you guys teachers? All right. This guy's like, yeah, I gotcha. So basically, what our pitch is to schools is buy a package of graders or of grading hours for your teachers, your English teachers or history teachers, whoever does a lot of writing, and we'll allow them to assign 2 or 3 more essays this semester. And so for schools that are really working on writing and literacy, that's a big deal because it means their teachers can assign more work without doing more work, hopefully, when it all works right. We're still really small. There's 4 of us full-time, so this is very early on. And really, I mean, it's fun. I love early-stage startups, so that's why I'm here. All right, so when I came in, this is a monolith of monoliths. It was all just one server. There was 1 commit from the whole last year, so I assume, I don't know what that means. I don't think they were using Git as the way you were supposed to. Do you guys know what environmental variables are? So API keys or secret passwords, things like that. You should typically keep them in a separate place from your code, but they were all checked right into the repository, hard-coded in there so you download it and you're doing everything in production. There was a whole duplicate code base in the main repository called Sandbox that I figured they must be doing their dev work in there, and they try it out in Sandbox and then copy and paste the files over to the main production application. And like, the last 2 are almost like secondary. Like, of course they had poor data and code structure. Of course they had no tests. Like, why would they? They've been like copying and pasting stuff with 1 commit the whole year. So as developers, we look at, like, everybody always laughs at this slide because it's funny to think about. Y'all are very early on and you know these are bad. That's good. That's really good. I'm glad to hear that. But sadly, a lot of code that lives in the real world is like this. I hate to say it. And not just at smaller companies. I mean, lately the data breach stuff that we all read about, whether it's Equifax or Yahoo or whoever else, I'm not going to say it's because they have a bunch of I don't think they necessarily have bad engineers. It's just that things get built a long time ago with totally different priorities, and years later, those things don't get updated because IT or us is an expense that some companies aren't willing to pay or don't pay enough for. So anyway, this kind of thing happens. The biggest problem they were facing was they needed a more reliable system. This thing obviously had a lot of problems beyond just the code stuff that sounds bad, like the thing didn't work half the time, and they would fall back to using Google Sheets and email to sort of like pass assignments around. I mean, remember the crux of our application is teachers need to be able to upload assignments with graded or with ungraded work, and then college students log in and get the assignment that they're allowed to get and pull down that data. And so that's kind of the main thing. And so when we needed to, we could fall back to just emailing stuff back and forth. We'd let the teachers email it to us. We'd email it to the right college student. It's not ideal, but it works. And we were a small enough scale back last year that it was okay. The first things that we did, I mean, obviously fixing version control is number 1. That's really, really helpful. Automating deployments. So going back to the whole, whether you're using microservices or not, the faster you can get code out to the real world, the faster you can fix problems, and the faster you can correct bugs that you make. We moved all the marketing stuff out to Squarespace. So this is something I see a lot of companies waste a lot of time, developer time on, is just updating marketing copy. So startups change their sort of pitch all the time. We're always repositioning ourselves to different users or consumers. We want to add a new page, we want to add a blog, we want to add whatever. There's no sense anymore having developers in-house do all that work. And it's extremely time-consuming because styling and marketing copy are just the bane of my existence. And it's not fun to do. It takes too much time. So pull that out into Squarespace. The application lives one place. Squarespace is the marketing stuff, and that lives somewhere else. We learned about, as we're doing this, obviously we learned a lot about how the application kind of worked and started to build a plan for how we're going to improve it. Now, the problem was that the assignment posting process didn't work very reliably, and that's kind of the core of what we did. So that was our first line of attack, was let's figure out what's wrong in the data model behind assignments, rebuild it into services, and then have the legacy application connect to those services to create and pull assignment data. So that's kind of what we did here. We sort of built some packages to share code between our APIs. Another thing that I've found helpful when building these microservices is, one, I like standardization, so I like each of the microservices to be very similarly architected, and then I like having a standard package that all of them use as kind of a baseline, just whether that's a framework or it's just like some testing libraries or clients that they're all going to use. Anyway, that helps. So as we're starting to pull things away from the legacy application and put them into our new microservices, we had found some parts of the old app that just didn't work right. So messages was one. We used to have a way for teachers to message students that were, or college students that were grading their papers and vice versa. That wasn't working very well, so we just like sort of cut it out for at first, and we started to reintroduce that by adding a users API that would control the data from users. So we're slowly taking responsibility away from this legacy application and moving it out into services. Next thing, we want better access to our data, and so we built what I call a transporter API, which basically just goes to each service, munges data together, and then sends a report back to admins. So I mentioned earlier that one of the challenges when building this way is that our databases aren't connected, so we can't just do a simple join between the courses and the assignments. Instead, we have to have these two APIs talk to each other and pull the data together in some way. So when it comes to exporting all the courses and assignments together, we have a new API that then takes care of that. There's pros and cons to that, so this is one of the trade-offs. Started cleaning and reorganizing the front-end stuff, and then started building a little Angular app that would handle the in-app grading. So up to this point, all the grading had happened in Excel spreadsheets. So what that means is the teacher uploads their assignment, they upload all the student work, the grader logs in, they download that work, they open up an Excel sheet, and they start writing in grades. So it's manual, but I mean, it works. We had hundreds, probably thousands of assignments graded that way. And well, obviously the downside is we didn't have good access to our own data. So the data about which students were scored well and which things we didn't really have because it was in Excel sheets, and exporting it out of there is a pain. So what we started to do was build an in-app grading process. And so that's where Angular came in. I guess like to sort of fast forward, now this is a few months later, the direction this is all heading, and did you ask about the API gateway kind of thing, like a layer? Okay, so this is the direction we're sort of going in this time around. We have all these back-end APIs, these microservices. We have an API gateway that they all connect to. And then all queries made to the APIs have to go through the API gateway. So the advantage to this is the API gateway can then control authentication, and it can check whether that user is logged in or that the OAuth token is valid or whatever login method you want to use. And then it'll make the sort of pass the request on to the correct API. So there's also pros and cons for that. The reason that I've sort of been moving this way is two things. One, we have this legacy application that's kind of already acting as a proxy, like an API gateway. So we're sort of just like slowly turning it into its own gateway. And the other thing is that I wanted to be able to open this up to third-party applications. So one of the things that we started to get requests for is like non-traditional users, so not teachers, want to send us assignments and then be able to pull the data of the graded work. So for example, we're not working with them, but an example would be the College Board. Let's say the College Board wants us to help grade essays. They would send us an API request with all their essays. It would create assignments in our system, and then we could send them raw data back rather than have them log into our system and deal with all that. So at some point, we're going to want access for third-party applications. Yes, and then, right, you guys will send us all your assessment scores. We'll do all the grading for everybody. Yeah?
And so from the client perspective, connecting to the API gateway, is there any discernible difference between a monolithic application?
No, and that's, I mean, really, for the client, there shouldn't be that much discernible difference either way, because all the client consumes, and when I say client, I mean the Angular front-end app or the third-party application. All that consumes is data in the form of JSON. So JSON data is just like a nice structured text data format. And so it doesn't care where it comes from. It doesn't care how many APIs touched it. It doesn't care if it was all one big monolith or a bunch of microservices, right? That's sort of all just like behind the scenes stuff. And that's what's kind of nice about the whole building APIs thing, is that as long as your API works the same way it used to work, it doesn't matter if you change the back-end architecture behind it. Yeah.
To what extent would like GraphQL and some of your tools change the next challenge?
So, I haven't done a lot of research in GraphQL, so I'd love to hear. I don't know, is anybody familiar with that? What that means even? No, you're the only one. Explain to us what GraphQL is.
Actually, Finch should probably do it. He's been
Okay, yeah, go for it.
using it for their project right now.
Oh, good. Okay. So how would it be different?
Yeah, so instead of having a wide collection of endpoints, you have only one endpoint, and you make post requests to it, and in the body of your post request, you specify what you want.
Yeah. So in a REST API, typically all the things that happen, the actions are driven by the HTTP call, the endpoint that you hit. Whereas in a graph, like basically a GraphQL system will take all of it through one post endpoint instead of having lots of different endpoints, and you just send it a payload of here's all the things I want. Yeah. Okay. Cool.
I guess to me seems like GraphQL is sort of serving in a similar kind of capacity to the API gateway.
So the GraphQL is just a way of formatting responses and requests. So it isn't itself a gateway. I mean, you'd still, if I wanted, right now we use a REST API structure, which just means you're hitting these resource endpoints and getting data back. If instead we want it to be a GraphQL-based request response, the gateway would just have to change what it responds back with and how it takes requests.
Yeah,
So.
I can see that would work basically
Yeah.
just like that, because like
Yeah.
with your GraphQL setup, you declare what the resolvers are. Like, okay, I know what the request is, how do I go get it?
Yeah.
That resolver can be whatever. It
Yeah.
could be a call to the database, or it could be a call to a different API.
Yep.
Even a different REST API.
Right.
Fine.
Yeah. Yeah, and I'm not really well versed in like the big picture advantages of a GraphQL sort of response system versus a REST API response system. We've used REST because it's just been used longer, and so a lot of times if it's not broken, don't fix it. But y'all are at a point where you're experimenting, learning new things. Nothing wrong with using GraphQL, and a lot of big companies are starting to use it and explore it for certain things. So definitely read up on that if you kind of want to see what else is out there. Yeah.
Have you found what sort of things have you found in terms of the backing databases for each service? That since it seems to me like you wouldn't as much rely on the strengths of a relational database anymore.
Right.
What do you back your services with?
So we back all these services with MySQL databases because it's easier to stay standard than to like have 3 different databases when there's only 2 developers. When these things start to grow and mature a bit, like say each of these APIs will kind of take its own direction over time. And as we get larger, we'll have different developers working on different ones, and the needs may become clear that, say, the Transporter API, maybe it doesn't really need a MySQL database, it just needs some kind of like temporary data store like a Redis cache instead, and that's all it uses. We could certainly go that direction, or let's say we had one that ended up becoming very non-structured, we could just back it with a Mongo database or whatever. So there's no reason that you have to keep them all the same other than developer simplicity. And I don't know if this has come out clearly yet, but I'm a big fan of like keeping things standardized when you need to, when possible, until it becomes like impractical or impossible. And at that point, it's time to start using specialized tools. We're not at the scale yet where specialized tools for different data structures or whatever makes a ton of sense. Yeah. But I like the idea of like having each of these be able to have its own backend. The other thing I like about this setup is, so we right now write in PHP because that's what I'm most familiar with, and the old legacy system was written in PHP and whatever. But in the future, we may switch to Node because let's say it's hard to hire PHP developers for some reason. They all get hit by a bus. So what we do is we just start slowly rewriting one service at a time into Node, and we don't have to do the whole thing whole cloth. We don't have to like have these weird Frankenstein systems. Each of these has an API that is a contract that it fulfills. As long as the Node app fulfills the same contract, it's fine. The other thing that's kind of cool is we might find a third-party service that replaces one of these applications at some point. And that's great, because then we don't have to maintain that code at all. Did you have a question?
Thinking, I guess my question is more about just kind of architectural planning in terms of like scaling.
Yeah.
It's just like if you're a startup, like you start out, like how much, like how much we can grow, how much are we actually, how much data we actually need to
Yep.
Like wondering how, like, does this, like, having it like microservices, it sounds like that kind of helps, like, compartmentalize that.
Yes.
Scaling one section of that.
Yes. So this setup will help with scaling in the future, but I don't concern myself much with scaling on a day-to-day like level at this point, especially because hardware is super cheap. And when I say that, I mean it might cost, I don't know, let's say it costs $1,000 a month to rent a ton of server space, right? That's cheaper than hiring a new developer. That's cheaper than half of a developer. So it's really, it makes sense to like go with technologies that you're more familiar with for as long as possible. So like whatever can get you developing stuff faster for as long as possible till you sort of hit the limits of that hardware. That's the way I look at it. So even though these are microservices, this stuff is all like tried and true technology. It's like PHP, REST APIs, MySQL. That stuff's been around for 15, 20 years almost. So this is not like, even though it sounds cool because I'm using this new term and things are talking over a network connection, this stuff is not that much different from a monolith when it comes down to like the technology choices. Yeah. But I'm like, I think as I've maybe matured, maybe gotten older, maybe gotten lazier, I've started to be more pragmatic in like that approach because I think a lot of startups are really concerned with scaling before it's even close to an issue. And I totally agree with that. So that's why at the Graide Network, we put all these on one server, not have each of them on their own server. We'll get there someday. You know, someday that'll happen, but it doesn't have to today. Yes? Yeah, it's a trade-off. So you're always just, I mean, like, I say that word a lot because it's just what we do. Like, we're constantly making trade-offs between accumulating technical debt versus doing stuff the right way, doing it faster versus doing it better, and there's no like one answer. So a lot of the way I think about this is how can I design the system or keep the system in a way that it can be most open to change in the future, because we're still at this phase where like none of these APIs are really like a version 1. They're all very like early on, immature. They change and break all the time. And that's okay, that's where we need to be at. But once we have larger teams and more developers on them, we'll want to think about, all right, this stuff's we gotta have strict versioning for each of these. We have to put them all on their own server. They have to be very isolated. They have to be like fault tolerant and all this stuff. So it's sort of like knowing that those problems are out there. I mean, I have a constant backlog of technical debt that I know I should do someday. But at the same time, the business needs to prove that it can make money and like scale up a little before we worry about some of that stuff. So you definitely take care of the like critical security issues. Don't leave those open. But the reality is when it comes to like, uh-oh, we can't handle 1 million users. We've only got 200. What do we do? You know, that's not a problem you have to face yet. You're probably gonna have plenty of time. And that's the other reason I go back to like the whole throw hardware at it as long as you can, because it's really cheap. So even if you don't have a bunch of developers to build this really cool system, you can probably get hardware for pretty cheap. Okay. All right. I have a couple other things. I kind of said all this stuff. Don't rewrite just because you can. Think about it. So, sort of my like takeaways here. With Packback, I learned using third-party software is a good thing, and use it as long as you can. And we do a lot of that at the Graide Network. I know I didn't include it in these slides because I was kind of focusing on a different thing. But almost every chance we get to build stuff into like using third-party applications, we take that chance because we're still really small and early. Rebuilds are hard, and I didn't really mention this in talking about the Graide Network, but one thing that's important when refactoring legacy code or dealing with legacy code you don't know how it works, is to write tests around it first and then start changing things. So when we started off, we took the old legacy system, we wrote some what we call acceptance tests, which basically just said, all right, when we go to this page, this stuff should load, and the user should be able to click here and log in and stuff like that, right? So we wrote about 100 of those before we really started changing any code. And that allowed us to know that when we did change things, we didn't break everything at least. I mean, we definitely broke things, but it was much better than if we had just gone at it without knowing what all was there. And that's pretty much it. Thank you guys so much. And anybody else have questions, I'll hang around for a bit. Okay.